Your human reaction time quantifies just how quickly you can react to a trigger. Now, this has obvious implications in our everyday life as we constantly react to hazards such as moving vehicles or even sudden changes to our environment like loud noises or bright flashes of light. Our brains are constantly reacting and making split decisions in fractions of a second in order to keep us out of harm's way and making sure that we interact with the things around us in a safe and appropriate way. Now, I'm going to show you a way that we can measure human reaction time in the lab using a reaction timer and a millisecond timer. Now, this is going to measure the amount of time it takes for me to respond to a visual stimulus. Now, this experiment's got some really nice links to competitive sports. So, for example, the starting pistol at the beginning of a sprint or the red lights at the beginning of Formula One. And in these two examples, human reaction time is going to play a significant role in the professional athlete's performance. Now, this is where you're going to hugely increase participation. Even the kids that might not have displayed an interest in science before are going to want to have a go at this. It's going to bring out the competitive side in everyone, and I guarantee everyone in the room is going to want to see how they measure up. So let me show you how to get it set up and I'll talk you through how it works. Okay, so the setup couldn't be easier. We've got two different boxes. One is the reaction timer, the other is the millisecond timer. So first off, we need to give the millisecond timer 5 volts. I'm going to put that in the back of the unit. And then on the reaction timer, we can connect it to that now using these two flying leads. So the one that says start gate can go in the start gate, gate 1. And the lead that says stop gate, this needs to go into the bottom socket, gate 2. Next, we need to make sure that the mode on the millisecond timer is on mode 2, which is gate 1 start, gate 2 stop. We can check that the green lights come on the reaction timer and then press reset on the millisecond timer to get the reading back to 0. Okay, so now it's ready to take a measurement and record a human reaction time. So I have to press the green button to let everything know that I'm ready. The light goes off. And then you saw that a red light appeared, and the red light is the trigger. So as soon as you see that, you need to press the red button to say stop, and then it will display your reaction time on the timer here. So this gives a reaction time of 0.569 seconds. Now, this doesn't count because I was showing you how it works. So let me hit reset to clear that value off. And I'm going to do it again, all in the same take, so you can tell that I'm not cheating. Can you still see everything? Yeah. Right, so I'm going to hit the green button. It tells everything I'm ready. The light's going to go off. It's going to come back at a random time as red. And to hit the red button to tell it to stop. And there we go. Let's do it. Oh, the concentration. Right, this gives me a reaction time of 0.173. Now I'm going to Google what the average reaction time is and either feel a lot better or a lot worse about this value. You will see how that research goes from the expression on my face in just a moment. Okay, so Google tells me that the average human reaction time is 250 milliseconds or 0.250 on the timer. So I've actually done pretty well here and I'm feeling quite smug. So you've seen just how much fun I've had doing this on my own here in the lab today, but if I had a playmate here to compete against, it would have been loads better. You could turn this into something like a beat the teacher activity or have a leaderboard up on the whiteboard. I just think it's a really nice way to help improve student engagement by gamifying your physics labs. You could also look at factors that might affect human reaction time. So you could take a measurement in silence and then play music and take the measurement again, and that might simulate having the radio on in the car. Or you could get students to have conversations with each other and be active in those conversations while they're trying to do the measurement. And that could simulate being on the phone and having a conversation whilst you're trying to drive. Now, some of you will be thinking, hang on, you've only taken that measurement once, how reproducible is it? And I fully appreciate that, and that is why I haven't taken the measurement again, because I know I'm not going to get anywhere near that. So in my next video, I'm going to take this measurement lots and lots of times and build up a huge data set. And from that, I'm going to see what statistics I can do with it. So I'm going to be talking about things like normal distributions, standard deviations, and errors. Now, you don't want to miss that because it's the whole reason why we take repeat measurements in science. So hit subscribe and I will see you next week. Thanks for watching.